this video we are going to learn about the structures of buckyballs, also known as Buckminster fullerenes, graphene and nanotubes, and what their importance are in an area of science called nanoscience. You may already be familiar with diamond and graphite as two allotropes of carbon. Allotropes are structurally different forms of an element. There's a video on this channel called Giant Chemical Structures that you might want to look at. If you have watched this video, can you remember the structural arrangement of the carbon atoms in graphite? Pause the video and resume when ready. The answer is that graphite exists as sheets of carbon atoms arranged in hexagonal rings. Fullerenes are carbon-based molecules with a hollow cage-like structure. Robert Curl, Harold Kroto and Richard Smalley discovered the most common fullerene in 1985, the Buckminster fullerene. It consists of molecules containing 60 carbon atoms joined together forming a hollow sphere. There is an alternating arrangement of hexagons and pentagons, much like that seen in a football. Can you think why the space inside the fullerene is of importance? Pause the video and continue when you have a suggestion. The answer is, the space is big enough for atoms and molecules to fit inside. Already, scientists are utilizing this to cage radioactive metal atoms and drugs. In one potential drug therapy, buckyballs containing cancer drugs are coated with a chemical that causes them to gather around cancerous cells. Once there, they deliver their drugs without harming healthy cells. Graphene is very similar to graphite, except there are no intermolecular forces holding the hexagonal arrangements of carbon atoms together. It has a two-dimensional structure. It has some very special properties which make it a material for the future. Despite being one atom thick, it is incredibly strong. The graphene can conduct electricity as efficiently as copper. The graphene is virtually transparent, yet is so dense that not even helium atoms, which are tiny, can pass through. So far, we have encountered two examples which both share a common theme, the fullerene. Fullerenes hold a special importance in nanoscience, a relatively new area of science which involves the study of nanoparticles. Nanoparticles are tiny particles made up of only a few hundred atoms. They can measure between 1 nanometer and 100 nanometers across. A nanometer is a billionth of a meter. To illustrate how small this is, a human hair is about 100,000 nanometers in diameter. Fullerene particles can be joined together to make nanotubes. These nanotubes have massive surface areas compared to their volumes, and this makes them excellent catalysts. You may recall that a chemical reaction takes place at the surface of a catalyst, and so having more surfaces enables that catalyst to work more efficiently. Nanotubes are the strongest and stiffest materials ever discovered. Often they are used to reinforce tennis rackets made out of graphite. All of these fullerene structures are revolutionary in the developing field of nanoscience. The nanoparticles mentioned here could be implicated in the development of new self-cleaning coatings in ovens and on windows, new types of computer processing, very strong and light building materials, and these fullerenes could be used as sensors to detect substances in tiny amounts, or to deliver drugs to specific sites in the body. In summary, there are three key nanoparticles, the Buckminster fullerenes, graphene, and nanotubes. These nanoparticles have a wide range of potential uses for the future.